So next up, we have questions 21 through 26 on the Unit 6 example question set. They act a lot like questions 1 through 6 did. That's an earlier video. They all are built off of this equation here. F of x equals x minus 4 times x plus 4 over x minus 4. I wish I'd put parentheses around that, but not that big a deal. That's more for aesthetics than anything else. So let's go through this and see what's what. I have made the questions a little different. On questions 1 through 6, I simply ask what is the vertical asymptote or the x-intercept or the y-intercept or the domain or whatever the other stuff is. Here I ask, does it have that? And if so, what is it? So 21, does the function this have a vertical asymptote? And if so, what is it? Well, in order to ascertain that, I need to know what's the whole first. So I need to find the factor that's the same bottom and top, if there is one. And sure enough, there is. This x minus 4 is the same top and bottom. Now, once I've gotten rid of that, if you look, there's nothing else left on the bottom. If there's nothing else left on the bottom, then there's nothing to set equal to 0, which means there's no vertical asymptote. So does the function have a vertical asymptote? We can simply put no here. 22, does this same function have a hole or multiple holes? And if so, what are they? Well, we have discovered that there is one. So we need to put yes, it has one, so we'll put yes, and then x minus 4 is what we're going to use to figure out the equation of that hole, or the x value of that hole. We'll set it equal to 0, we'll add 4 to both sides, and we get x equals 4. So yes, I probably should put comma at x equals 4, something like that. Number 23, does this same function have a horizontal asymptote? And if so, what is it? So remember, to find the horizontal asymptote, we need to find the degree of the numerator and the degree of the denominator. And to do that, we multiply all the stuff that is the first term in each factor, if you will. So on top, we're going to multiply x and x. On the bottom, which is just going to be a single x. So we get x squared over x. And just to be clear, if we haven't written in an exponent explicitly, like we did here, then we assume that it is 1, not 0. Anything to 0 power is 1, and that would get rid of our x on the bottom. So I'm looking at this. I have a degree of 2 on the top and a degree of 1 on the bottom. That means the top exponent is bigger. And when the top exponent is bigger, then there's no horizontal asymptote. So does this function have a horizontal asymptote? No. 24. Does this same function have an x-intercept or multiple x-intercepts? And if so, what are they? And we even reminded you to write your answer in ordered pair form. So the process for this is, once again, get rid of the whole, which we know is x minus 4. And whatever's left on the top, you set that equal to 0 and you solve. So we'll put x plus 4 equal to 0. We will solve it by subtracting 4 from both sides. We get x equals negative 4. So certainly there is one. It did not turn out to be undefined. So our answer, does this have an x-intercept? Yes. And that would be negative 4, comma, 0. Does the function have a y-intercept? It's a great question. I would say the best thing we can do is, well, I say the best thing. What we need to do is get rid of the whole, and then plug zeros in for our x's. So on top, that would give us x plus 4. On the bottom, we've eliminated the only thing that was there. And so I'm going to do much like we did in the previous problem where we did that. And I'm going to remind you that when in doubt, you can put a 1 here. Pretend like there is a 1 coefficient. You need a placeholder or something. You could always make a fraction by putting it over 1. So this ends up equaling 4 over 1, which is just 4. That is clearly a y-intercept. So does it have a y-intercept? Yes. And it will be at 0, comma 4. Whew. Now, number 26, I didn't ask, doesn't have a domain. Of course it has a domain. We've talked about this. It has to have a domain. We just need to identify what it is. So we know that domain is going to be written, for our purposes, x is not equal to, and then it's not going to be equal to the vertical asymptote or the whole values. Well, there wasn't a vertical asymptote. So we don't have to worry about that. There was a hole at x equals 4. So we have to say that the domain is that x is not equal to 4. And that's about all there is to that.